let me start recording here again. So so there's more than 50 different types of barcoding, and we're just going to look at a couple of them, and they'll give us a good idea of, you know, how or why the other ones work. But you know, these just kind of are a couple of focus ones we're just going to focus on here. So there's code 39, interleave 2 of 5, UPCA, and QR code. So those are the ones we're just going to look at here. Okay. So interleaved 2 of 5. This code represents only represents numbers. Okay, so we can't have any letters or symbols of any sort in here. We can only have the numbers in this code. All right, but it's nice. It'll work for pretty much any kind of printer can print it out, and we can store quite a bit of information in a really small space. Okay, so you know, so here's an example, and the way this works is we have 5 consecutive black bars, and those 5 consecutive black bars can represent a 1, 3, 5, 7, or 9. Each number will always have 2 wide bars and 3 narrow bars, and it's just a matter of what order they are in. Okay, so, and again, this is a code. The reason we do this is because we need to be able to scan it. We need to be able to see it very easily with our scanner or camera that we're using to look at this code. And then so it needs to be quite visible. And we need to be, you know, we can't get confused. We can't think it's a 1 when it should be a 5, or 3 when it should be a 1, right? So we can't let it get confused. So, you know, so this code is laid out in such a way that it is extremely reliable. All right, so each number will always have 2 wide bars and 3 narrow bars. And the black bars, 5 consecutive black bars, will give you a 1, 3, 5, 7, or 9, depending on the pattern of wide and thin. Okay. Now, of course, in between every black bar is a white bar. Okay, or a white space, and those give us the 2, 4, 6, 8, or 0 numbers. Okay, and so the even numbers are given to us by the white spaces in between the black bars. So the black bars give us the odds, the white spaces give us the even numbers. Okay, each number will always have 2 wide spaces and 3 narrow spaces. All right, and so we can interleave these. 1 odd and 1 even number is always grouped together, right? Because we always have white spaces, and the black spaces or black bars and the white bars are always there, right? So you're always interleaving an even number and an odd number with the spaces and the bars. All right, so you can see here, this is just kind of showing you an example. I'm not going to ask you to try to read this by eye and understand these codes. I just want you to understand, you know, like how they work and those aspects on it. Okay, so another option is the 3 of 9. So it's code 39, 39, or actually 3 of 9. All right. And so this barcode now can actually represent alphanumeric characters and or some special characters like a space. Okay, a lot of people, when you say, like, you know, tell me what's in between this L and L and this B, and a lot of people say there's nothing there. Well, that's not true. If there's nothing there, it would look like this. Okay, this here has nothing between the L and the B. Can you guys see that? Is that showing up on the screen there for you? Right now, between the L and B, there is nothing. If I come over here, I put the cursor there and I hit the space bar, there is something between that L and that B. It's a space. Okay, spaces are tremendously important. And if I had this slide and I just like removed all the spaces in this slide, I don't know, could I do this? I want to look for a space and replace it with nothing. Right? So, if I remove all these spaces, this is what I get. Right? It seems all jumbled up, right? It's almost impossible to read. Fortunately, I have Control Z and I can recover from that. Okay, so spaces are tremendously important, and it boggles my mind so much when people look at that and they say, well, there's nothing between there. And in computer terms, there's absolutely something there. It's a huge difference between nothing and a space. Okay, but this code, this bar 39 code, has it can do letters A through Z. Notice they're just capital letters though, not lowercase. It can do numbers 0 through 9. It can do a hyphen, a period, an asterisk, a $sign. So there's and several other characters there, and then of course, like I say, the space, which is so important. All right, so this code can encode all of this information. So there's a lot more information, obviously, that we can kind of embed in a code 39. All right. However, this code can get quite long. Okay, so we'll have to look at that here when we look at some of the aspects of the code. This code now gets very, very long, so it's not going to fit in such a small space. Okay, but this code is used widely in both industry and the Department of Defense. So how do we read this? Well, every character, whatever it is, right, whether it's a star, a space, a letter A, letter B, letter Q, right, whatever it is, it all has 5 black bars and 4 white spaces. Okay. Of these 9 elements, you're always going to have 3 wide and 6 are going to be narrow. So that could be like 3 wide black bars, and everything else narrow, or it could be 3 wide white spaces and everything else narrow, or it could be 1 wide black bar and 2 wide white spaces and everything else narrow. All right, so notice 5 and 4 is 9, and 3 and 6 is 9, right? So that's where the 9 comes from. Okay, where does the 3 come from? 3 of them are wide. So there's your 3 of 9 code. So you've got 9 things, 5 bars, 4 spaces in between the 5 bars. Okay, and then you've got these elements in here. Okay, so it's sometimes also referred to as a 2-width code. Okay, now as I said, we don't necessarily know how long these things can be. So these codes, these 39 codes, can get really long, and so we always have to start and end them with something. So they chose the star or the asterisk, however you want to call that. Okay, so any encoded value will always have a star will be the beginning of the code, and then a star will be the end of the code. Okay, and then each character is going to have a space in between it. So let's take a look at, well, I thought I had a picture of it here, but I guess I don't even have a picture of it. If you look at the beginning of the slides, there was a link that showed you, and there'll be some examples in there. All right, so with the creation of smart devices and stuff, we've really seen 2-dimensional codes pop up a lot more often. So the 2 of 5 code here or the 3 of 9 code, those codes are one dimension. It's just one long bar. So that's why we call it a bar code, because it's just one straight line. But now, you know, with the modern technology and these cameras, they went to QR codes. QR codes are some other two-dimensional codes. Okay, so the QR code is just one version of these two-dimensional codes. But the idea is you got, with the two-dimensional code, you can put in a lot more information than through a single linear bar, because now you got height to it. The problem with these, of course, is the fact that you need to know the rotation. So when you look at this, you see the corners, 3 of the corners have an obvious kind of design on those corners. So you can look at that and say, boom, I know exactly what that is. All right. And so you know, no matter how your camera is oriented, you can take that picture of that, and then the software can rotate it and get it lined up in the proper orientation so that you can identify that. So you can put a lot more information in one of these two-dimensional codes. Okay. And one of the most obvious things they do with the QR codes, they put in what's called a uniform resource locator. So they, you know, you see these a lot on, I don't know, magazines and stuff. They send you, and it has a barcode in it, so you can then take the picture and it'll take you immediately to the website. So they, you know, they feel that a lot of users prefer to take a picture of the code and hit the button and go to the website, as opposed to giving them an address like, you know, Amazon.com or starkstate.edu and asking them to go type it in. Oh yeah, use a keyboard? What's that, right? So so that's kind of the idea with these QR codes. All right, another code that I think is kind of important to talk about is the Ascii code. And Ascii actually stands for American Standard Code for Information Interchange. Okay, and this is a code for sending data between two computers or two devices. And so, and of course, you know, the fact that it starts with A for American, it's an American code. It's not really international. And but it's kind of, the idea here is that you can only have inside your computer, you only have binary information. So everything's a bunch of ones and zeros. So when you look at the letter A here, so we look at the letter A, or we look at the letter C, or look at the letter W, right? Each one of these are different letters, but inside the computer, they're made up of a group of ones and zeros. All right, and even if we look, like, here's a capital A, here's a lowercase a. Well, those are different, right? There's a huge difference between a capital letter and a lowercase letter. And so if we're going to encode uppercase and lowercase inside of a computer, we got to have a different set of ones and zeros for a lowercase a than we would for an uppercase a. And so the Ascii code maps all the letters A through Z in both capital and lowercase. It maps spaces, as I pointed out before, right? Spaces are really important. Spaces need to be mapped. It maps out periods and commas and other punctuation and some other things. But the original Ascii code was only 127 digits, or excuse me, 100. The original code was 7 bits. All right, and so 7 bits gives you 2 to the 7th. 2 to the 7th power. Where's my? Well, I can't get a, don't want to pop up my thing there. 2 to the 7th power gives you 128 possibilities. Now, the first of those possibilities is 7 zeros. Okay, and that is a special null. That's the null code that's kind of used for certain things. Okay, that's a huge difference than the space. Okay, and then the highest of that would be 7 ones, right, which is 127. Okay, so you have 128 possibilities. The first possibility is 7 zeros, and the last possibilities is 7 ones, which gives you a maximum number of 127. Okay, and so there's only so many characters you can map in the original Ascii code. Okay, so like if we went over to Europe, like in Germany, and other countries, they use some other symbols than we use here in America. And so they ended up coming out with something called the extended code. And the extended code used 8 bits. Okay. And the 8 bits gave us 256 possibilities. And so that allowed us to include special characters like all the Greek letters, and other special symbols that are used in other languages like German or Russian or something like that. But it still didn't allow us to encode things like the Chinese letters and a lot of the Asian countries and their symbols, because they use so many of them. And I mean, I've been told, I don't really know Chinese, and so I don't know for sure, but I've been told there's like something like at least 400 characters in the Chinese language. Well, using 8 bits, we can only map a possibility of 256 possible symbols. And so what they did is they came up with something called Unicode. And Unicode is the 16 bits. So you got 16 bits. Now with the 16 bits, then this gives you a possibility of 65,536 unique possible patterns. And so that allows us to map the entire English language, the Russian language, the German language, the Chinese language, the Japanese language, and like every language on the planet. And all the characters that they use in all of these different languages can be embedded inside of this Unicode. All right. So now the Unicode was expanded. So the first 100, actually, the first 128 are the original Ascii code, and actually the first 256 are the full extended Ascii code. And then from above there, then they go in and they're able to encode characters of all the various languages around the world. Okay, so you'll see this Ascii and this Unicode referred to a lot. And the last slide here, I just show you the mapping between decimal, and it's kind of blurry there. But you can just go to Google and do a search for Ascii, and they'll give you you can find a listing of this showing you the map. Because remember, everything inside of a computer, whether it's a robot or your PC or your smartphone, everything is really binary. And so when we want to display the letter A, or we want to store the letter A in a document and then have it displayed, it needs to be able to read that binary code of ones and zeros and convert that to what it's going to display on the screen, which is basically a saved image to make it look like an A to us. Okay. And so we have to encode these values. So, but that covers the barcodes and scan codes and the ASCII code and stuff for this class. So